We're going to test if a mean is where we might think it is. So if we have evidence to change our mind. So first of all, we have to start with a null hypothesis. So our mean is some assumed value. Not the mean from the data, but the mean from the assumption. And we'll practice that. So H naught, it's always mu equals. The alternate hypothesis is the one you're seeking evidence for, and it never uses the equal sign. It might use the greater than, the less than, or the not equals to. And remember to identify what the parameter is in context. Okay, so one of the things we're going to be finding is something called the p-value. And that represents the probability that we could see the results we saw if our assumption is actually true. So why do we reject the null hypothesis? In other words, why would we change our mind? Well, if the p-value is low, that means it's highly unlikely we would see the data we got, given that our assumption is true. And since that's unusual, we're like, oh, we should change our minds. And it means we have convincing evidence that HA is true. Okay. Why do we fail to reject the null hypothesis when the p-value is above our alpha? Well, if the p-value is high, then it means that it's highly likely we could see the outcomes given that H naught is true, and it means that the evidence for H naught is not convincing. So let's go ahead and practice doing our H naughts and our HAs, our null and our alternates. We have a pharmaceutical company calibrates its manufacturing process. So the mean atorvastatin content in a pill is 40 milligrams, and the population standard deviation is 0.5 milligrams. Data from a random sample of 10 tablets gets a mean dosage level of 39.7 milligrams of atorvastatin. They test the idea that the sample is different than the specified level of 40 milligrams and get a p-value of 0.058. So what is our null and our alternate? Well, we're going to assume that the manufacturing process is okay, that it is 40, but we're worried that it's not. So do we reject H naught? Well, we have to look at our p-value. Our p-value is 0.058, which is greater than 0.5. Okay. Oh, by the way, the reason I have these two shaded here, the reason these two are shaded right here is because this represents mu is not 40. So too low or too high is included in the evidence. Well, when we include both, our p-value is 0.05a, and that's greater than 0.05. So no, we fail to reject H naught. We do not have convincing evidence that the mean dosage level is not 40 milligrams of atorvastatin. All right, now we're going to change it. So we're looking at just less than. We're just worried that it's less than 40 milligrams. So our H naught is the same. We're still assuming it's 40, but we change our HA to 40, which changes our shaded area to the less than side, which halves our p-value. It's 0.029. Now that is less than 0.05. And yes, we're going to reject H naught. So that means we have convincing evidence that the mean dosage level is not 40 milligrams of atorvastatin. Okay, so conditions are the same for t-test as they are for t-intervals. We have the large normal condition, so n is greater than or equal to 30, and or the population is approximately normal. Okay. We have the random condition. The data come from a well-designed random sample or randomized experiment. Note that being representative is the goal of this condition. So let's go ahead and we're going to look at two examples. We're going to do the beginning parts of our hypothesis test, which is create your hypothesis and check your conditions. So we have a coffee machine that dispenses coffee into paper cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the amounts measured in a random sample of 20 cups. Is there evidence that the machine is shortchanging the customers? All right. So we've got 10 ounces of coffee, so that's what we're supposed to be getting. That's our null. We're worried about shortchanging, so we're worried it's less than 10 ounces of coffee per cup. So let's check the conditions. First, I'm going to check, is it random? They told us it said random sample right here. All right. So, and then we have to know, is it greater than 30 in our sample? No, this is not more than 30 cups. You can just count. And so what we have to do is just look at the plot of the data, and I went ahead and created that for you. So if the plot's roughly symmetric, in other words, no major outliers or anything crazy, and it's unimodal, roughly unimodal, it's fine. The condition is met. You have to have a really crazy plot to reject this. Now we'll do another example. The company has set a goal of developing a battery that lasts over 5 hours, 300 minutes, in continuous use. Based on the sample at right, is there evidence they met their goals? State the hypothesis and check conditions. Well, we're going to assume that they just barely got 5 hours. They're trying to get over, all right? And then we're hoping that it's greater than 5 hours. That's what we're collecting evidence for. First, we're going to check, we'll check the large normal condition. So it's not greater than 30, our sample size. So we have to check the plot, which is roughly symmetric and unimodal. So we're good. All right. In this case, that the sample is random or at least representative. The whole point of randomization is to make sure that our mean is not biased and that our sample is representative. It's not telling us up here, so we're going to have to assume. So here are the steps to run hypothesis tests. Once you have checked the conditions and set up your hypothesis, we use the alternative hypothesis to determine the p-value. We're going to calculate the test statistic. If doing p-value by hand, most of the time we're using technology, and it's going to give us both the test statistic and the p-value. All right. Compare the p-value to the alpha level. If alpha is not given, use 0.05. Reject or fail to reject the null hypothesis H0. Reject if the p-value is less than the significance level, and fail to reject if the p-value is greater than the significance level. Determine if there is sufficient or insufficient evidence for the alternative hypothesis. So calculations, you're rarely going to have to do these. We are using a t instead of a z, and this is the formula for the test statistic. It's the sample mean minus the hypothesized mean over your standard error for your sample divided by the square root of n. N is your sample size. Now you're going to use your alternate hypothesis to determine how to shade the student's t-distribution to show what probability you're seeking. So there are 3 forms. You've got the left-sided, which is left, and you got your p-value there. There's your number from minus infinity to your t-score. There's a 2-sided where you're doing both left and right. And so you can just do the left side and double it, okay? And then there's the right-sided alternate, and you shade to the right. And your left value is, the left boundary here is the t-score. Let me get my pointer again. So this boundary right here is your t-score, and then you're going to positive infinity. So this is negative t-score, positive t-score. This is a negative t-score. Usually, it's rare you're going to have a positive t-score and going left. Usually, these are smaller values than half for probabilities. Now, the good news, running a hypothesis test for a mean on stapplet. So how do we enter the data? So you select one quantitative variable, single group, enter your data, and click on Begin Analysis. Or, if you don't have data, all right, but you do have summary statistics, click down on the drop-down that says Input, and change that to mean and standard deviation instead of raw data. Enter your mean, your standard deviation, and your sample size, and then you click Begin Analysis, all right? So after clicking on Begin Analysis, scroll to the bottom until you see the words Perform Inference, which you can kind of see right there. Select one sample t-test from you, all right? Make sure that the alternative hypothesis is in the correct direction, because there are 3 options here. It can be greater than, it can be less than, it can be not equals to. So make sure whatever this is matches your hypothesis. So if you're getting the right test statistic, but the wrong p-value, it's because this is wrong. All right, so make sure that's correct, and then put in your hypothesized mean. The test statistic is under t. So it'll give you this report right here. There's your p-value. It should be a number from 0 to 1. Stapplet's never going to give you something else, but there's a hint. A test statistic can get big. A p-value is a probability, so it can only be between 0 and 1. And remember that your degrees of freedom are n to 1. Okay. All right. So let's show you how to run through. Okay, so here's a quick run through now that you've gotten all the directions on how to do it. This one we're doing with raw data. So I'm pasting my raw data in here, and I think there's an ampersand in my data set. So get rid of that symbol. It doesn't like it. Begin analysis. And you scroll on down until you see perform inference here. All right, and then you go one sample t-test, because we're doing a test, and our hypothesized mean is 300. Click perform inference, and there are your values right there. There's your test statistic, your p-value, and degrees of freedom, which you can see is just one lower than n. So there are two ways our conclusion should look like. One is when p-value is less than the alpha, then we're rejecting H naught, we have convincing evidence. Other one, when the p-value is high, greater than alpha, so it's not that unlikely, so we fail to reject our assumption, and we have insufficient evidence for the alternate. All right, so let's go ahead. We're going to use the test statistic and p-value from this stapplet report. This is the one I just got in the little short before. And we're going to write a conclusion. So this one, the p-value is greater than 0.05, all right? So this is our context here. So if you're trying to do your cheat sheet for your test, these two sentences are something you want to write down. So because our p-value of, in this case we obtained 0.2378, is greater than 0.05, we fail to reject H naught. There is insufficient evidence that the true mean is not greater than 5 hours. Probably would be nice if I said the true mean battery life. That actually would be better. All right, and then we've got one final example for you where we have a mean and a standard deviation. So to run the t-test using summary data, mean and standard deviation, make sure you click the drop down here, because before, this is what it defaults to, which is where you enter the data. But in this example, we're just going to put in the mean, which is 9.845. Our standard deviation is 0.1986, and n is 20. There are 20 cups in our sample. Then we're doing a one sample t-test from you, and in this case, we were checking to make sure we're supposed to get 10 ounces of coffee, and we're worried that it's less than. You can see our sample's less than, right? And then we click perform inference, and there is our p-value right there. Negative 3.49 is our test statistic. Our p-value is 0.001224. And your degrees of freedom is 19, which is one less than your sample size. So we have our test statistic and our p-value. And it's always nice to have your degrees of freedom, which in this case is 19. So how do we write our conclusion? Our p-value is very low. So we use this little piece right here, p-value less than alpha. Because our p-value is 0.001224, and it's fine to include extra decimals most of the time. You might get bit if you round too much, so throw in some extra decimals. That is less than 0.05. We reject H naught. There is convincing evidence that the true mean ounces of coffee is less than 10 ounces of coffee. And that is your intro to